Hello again. In this lecture, I'll introduce text and internationalization. In particular, I'm going to explain the following: text encoder, text decoder, text conversion, and locale namespace. The encoding class is the base class of each individual encoding class. This class provides functionality to convert a string from a specific encoding method to Unicode and convert Unicode characters into an encoded string. Bada provides the ASCII encoding, GSM encoding, Latin 1 encoding, USC2 encoding, and UTF-8 encoding functions by default. You can get each encoding object by calling the relevant getEncoding function. To find out which encodings are supported, you can call the getAvailableEncodingsN static function. This will return a list of encoding names. For example, an item name in the list can be ASCII or UTF-8. To select the required encoding type, call the getEncodingN function with the name string of the encoding object. Now, I'm going to introduce the basic terminology used in the encoding class. In Bada, char, or character, refers to a Unicode character. A string refers to a Unicode string. A byte refers to 1 byte of an encoded string. Now, let's see how we can create an encoded character string from a Unicode string. The encoding class provides functions to get the number of bytes the encoded string will contain and to encode the string. You can also query how many bytes are required for storing an encoded string based on the number of Unicode characters in the string. Similarly, for decoding an encoded string to a Unicode string, the encoding class provides functions to get the number of characters the decoded string will contain and to decode the encoded string. You can also query how many characters a decoded Unicode string will contain based on the number of bytes in the encoded character string. Additionally, the convertN function is provided to directly convert an encoded character string into another encoded string without converting it to Unicode. Let's see how we can use the encoding class in more detail. You can get the required encoding class by calling the getEncoding function. To decode a string, you can call the getString function of the encoding class, with the buffer containing the encoded string and the string to save the converted string to. To encode a Unicode string, call the getByteN function of the encoding class, and you'll get a pointer to the byte buffer containing the encoded string. Let's use an example. First, I get the ISO 8859-2 encoding object by calling the getEncodingN static function of the encoding class. To test this encoding class, I created a Unicode string. The getByteCount function is used to get the number of bytes required to encode the Unicode string. The getByteN function is then used to encode the Unicode string into a byte buffer. The getCharCount function is then used to get the number of Unicode characters required to decode the encoded string in the byte buffer back to Unicode. The getString function decodes the encoded string, saved in the byte buffer, into Unicode. Finally, I compare the decoded string and the original string, and if the strings are the same, the "Yes, the encoding class is working fine" log message is output. Of course, when this source code is executed, the "Yes, the encoding class is working fine" log message will be displayed. Besides the encoding class, encoder and decoder classes are also provided. These classes are used to encode or decode a relatively large amount of data. To support a large amount of data, parts, or blocks of data, are converted in a sequence using successive calls. What this means is, if you put the buffer containing the first part of the data into the encoder or decoder, perform the conversion, put the buffer containing the next part of the data into the encoder or decoder, perform the conversion, and repeat until the last part of the data is converted, you can get the same result as if all the data was converted at the same time. You can use the functions as follows. Now, let me explain the locale namespace. The locale namespace includes various classes for internationalization. The classes include the locale, locale manager, calendar, Gregorian calendar, date-time formatter, date-time symbol, number formatter, number symbols, currency, time zone, and time rule classes. Let's take a look at the functions provided by the most important class, the locale manager. The locale manager provides a list of all the languages, locales, and time zone IDs that can be used by the device. It also provides a function to evaluate whether a specific locale can be used on a device, or if it's not supported. Additionally, functions are provided to query the language, locale, and time zone that are currently set in the system settings. The locale class represents a specific geographical, political, or cultural region. The locale class contains information about the region's language and country. The locale class is created using the language code, the country code, and additionally, a variant code string. You can get the language code string, and language name values from the locale class. The language code is an enumerated value. The language code string is the ISO 6392 string representation of the language code. Finally, the language name string contains the name of the language. A language name string can be retrieved from the locale class using either the current locale or for a specified locale. If you request a language name without specifying a locale, the string will be returned in the currently selected locale. But, for example, if you request the language name specifying the French locale, even if the current locale is English, the French string anglais will be returned. The country information is similar. The country code is an enumerated value. The country code string follows the ISO 3166-1 Alpha 2 code. The country name string contains the name of the country. As with the language name, you can retrieve a country name for a specified locale. Now, let's have a look at the time zone class. The time zone basically performs the conversion between UTC, that is, Coordinated Universal Time, Standard Time, and Wall Time. UTC is a standard time system, such as GMT. The standard time is the local time without daylight savings time. The wall time is the local time considering the daylight savings time. The thing you have to remember is that since the time zone class does not have a clock, you have to provide a reference time in order to get the time of the relevant time zone. Number formatter converts a number into a specified format and helps format numbers for a specific locale. For example, it's similar to changing the format of a number when you enter a number in a spreadsheet program like Microsoft Excel. The supported patterns include grouping, grouping size, negative number, prefix for positive number, minimum, maximum decimal places, and the minimum, maximum integer places and currency mark. The Create Currency Formatter, create number formatter, and create %formatter functions are provided so that you can get an appropriate number formatter by specifying the locale. Now, let's see how we can actually use the number formatter. In this example, I created number formatter without applying a locale and used the formatter to convert the number 12345.6789 to a string. The resultant string is 12,345.679. Then I set the max fraction digits to 1 and used the formatter to convert the number again. The resultant string is 12,345.7. You can see that since the max fraction digits is set to 1, only the first decimal place remains, and the value is rounded to the first decimal place. Then I set grouping used to false to cancel any grouping. So the comma for 1,000 is removed. The resultant string becomes 12,345.7. Next, I'll introduce the calendar class. The calendar is basically an abstract class that provides functions to identify the day of the week, the day, the month, and the year of the specified date. In addition, the class provides a function to compare two calendars and the arithmetic functions to add or subtract a date from another date. For example, you can calculate the date and time 40 hours from now. The class in which this calendar abstract class is implemented is the Gregorian calendar class. Next is the date-time formatter class. The date-time formatter class converts the specified date and time to a string appropriate to the locale. In addition, you can change the formatter as required using the date-time symbol class or by applying a specific pattern string. Now, let's have a look at an example. In this example, I get the system locale from the locale manager and create a date-time formatter with the locale. Then, I get the current time from the system and convert the time to a string. Since the locale I used in this example is an English region, the date is printed as 27th July 2010. Then I applied a pattern to the formatter. The characters in the pattern string are as follows. M means month, D means date, G means BC or AD, and Y means year. After that, the hour, minutes, and seconds are delimited by colons. The A is added to represent AM or PM after the time string. When the current time is converted to a string using this formatter, the result is July 27th, AD 2010, 7:31, 12 seconds, PM. Now, let's wrap up the text and locales namespaces. The text namespace supports converting between encoded text strings. Since a bada string is basically a Unicode string, you can convert a file or data containing non-Unicode characters into Unicode, and to convert a Unicode string into an encoded string for data transmission. The classes included in the locale namespace are used to internationalize an application. Especially the formatters such as the number, date, time, and currency formatters convert the number, date, and time to an appropriate format for the country or language. The time zone class converts the standard time to the local time.